Welcome back to the channel. In the last 3 episodes, we have been discussing a point forecasting competition where an expert who is able to correctly infer the true underlying distribution competes against naive forecasters who have basically no idea about that distribution. Obviously, we want the expert to win, but as we have already seen, that is by no means guaranteed and depends on the point from the distribution that the expert decides to submit as her point forecast and the metric used to rank different participants. From the previous episode, we know that when she submits the expected values of her correctly inferred distributions for each test day, she wins under the mean squared error metric. We also know the reason for this, which is the fact that the expected value of a distribution is the point which minimizes the squared error loss under that distribution. Feel free to watch that episode for a refresher on this. In this episode, what we will learn is which point from a distribution minimizes the absolute error loss under that distribution. In other words, in a competition where the error metric is mean absolute error, which point should be submitted as point forecast? The way we will answer this question is by having a mathematical derivation similar to the one we had in the previous episode. I recommend that you watch that episode for a visual intuition behind the derivation and also for the meaning of related but different symbols such as y, y hat, y tilde that will be used in our derivation. We start by writing an optimization problem where the objective is the expected value of the stochastic absolute error loss. Simply substitute the definition of the expectation operator. Break the integral into 2 parts, y values below y tilde and above y tilde. Take y tilde out of the integral, just like we had in the last episode, and because of the first derivative test, set the derivative of the term inside the brackets with respect to y tilde equal to 0, which will give you this equation, which is the definition of the median for a continuous random variable. This is telling us that under the absolute error loss, the optimum point is the median. In other words, it is the median that minimizes the expected value of the absolute error loss. Now, let's go back to our competition, but this time, instead of the expected values, our expert submits the median of her correctly inferred distribution for each test day as the point forecast for that day. By looking at the test errors, you see that with the medians, she gets the lowest mean absolute error among all participants. In other words, medians let her win under mean absolute error. Now, the question is, with the medians, will she still win under mean squared error? And the answer is no. She will lose to the naive forecaster who submits the average training value as a uniform forecast across all test days. So, what we learned from this and the previous episode is that when the metric is mean squared error, the expert has to submit the expected values of the inferred distributions. When the metric is mean absolute error, she has to submit the medians of those distributions. In the next episode, we will discuss what she should submit when the metric is made. Thanks for watching. If you have any questions or comments, feel free to reach out. Also, don't forget to check the GitHub repository of the channel for more details.